Okay. So hello from my side. I'm today your diversity element here. I'm industry, not defense or whatever. I'm European, and I'm actually a SysML guy, so I'm pretty new to UAF. First time here. I appreciate that. And one thing which relaxes me a little bit here is I was afraid that I'm the cobblestone in front of your lunch. Now I learned that we don't have lunch, so I have many time, I hope. Sure. Okay. So I'm staying here and talking about production systems and modeling production systems. And as I said, James made a perfect lead over to us. And John Deere is on its way to a model-based company, to a digitized company. And I would like to introduce you a little bit why we started dealing with UAF and what we expect from that and what we achieved already. I start introducing myself, and you see here I'm that kind of SysML modeling guy. I did my CV as a model, as a block diagram. In a nutshell, I'm working since 20 years with John Deere. I'm responsible, and you see on my shirt, I'm a tractor guy, right? So I'm perfectly tractor guy. I'm leading the systems engineering efforts in the tractor business globally. I'm engaged in some associations like the INCOSI and the German chapter of INCOSI and others. And I'm a family father. I'm a motorcyclist. I'm also a customer. I own my own tractor, even if I don't use it for agricultural behavior, more for wood making. It's a lot of fun. And I'm a grandfather. I'm a pretty proud grandfather. I would say grandchild is one of the most complex systems you can ever try to manage. So John Deere, and we also had from James a good lead into enterprise transformation. At John Deere, we are around with systems engineering since more than a decade. And after a while, we figured out, is any one of you aware of Conway's law? Melvin Conway? Okay, and we figured out, unfortunately, he's right? If you develop a system, you are and we transformed everything that the platforms are not anymore in the focus, in the main focus, or not the tractor, the combine, or whatever, but the production systems. So our highest system of system is either, if I would be a construction guy, so if there would be an excavator or whatever, it would be the work site, the construction site. I'm a tractor guy, so my highest system of systems is the farm site. And a farm site can have many production systems. You may have at the same time cattle for dairy, for example, and you may grow small grains like wheat or barley or whatever. Underneath that, we have what we call the solution systems, so machine combinations, system combinations, and then the original platform systems come. And further down, we do what systems engineers always do. We decompose them to smaller parts and pieces. So now the full focus of our offering to the customer changed, not anymore thinking about how can I make a tractor more fuel efficient or how can I make a tractor more versatile or more agile, but identifying what does a customer need on a production system level to earn money, to make his business profitable, to make his business sustainable, and trying to figure out how we can best support him in that. And that may drive changes to the tractor. I come later to that in more detail, but a simple example, if you analyze that and you figure out what are the costs in a farming operation, fuel may have cost and workforce may have cost. And in some cases, it can be that even if you can save a little fuel, the overall savings for the customer are less than if you introduce automation to a tractor and enable a less skilled, cheaper operator to operate the tractor same efficient. This is what comes from a production system perspective, in a nutshell. Okay, so dairy and livestock farm from the viewpoint of a systems engineer. You thought about, you know what dairy and livestock farm is. I confuse you now. What we did with a dairy and livestock system, we separated that in two bigger concepts of operations, two bigger CONOPs. So one on the left hand is a forage production system, which produces basically the food for the animal, and the other one is the animal production system. And from a production system point of view, from an enterprise point of view, what you see, we have inputs like energy, like money, like agents, fertilizer, spraying stuff, whatever. And we consume greenhouse gas, so we are the good guys, right? If others produce CO2 or whatever, we consume greenhouse gas to grow plants. And in that production system, then we have activities, use cases, ops, cons, you may name it how you want to, like storing stuff, like preparing the field, like sowing the plants, the crop for that food, nurturing, protecting, and harvesting. This food is then carried over into the other concept of operations, where we feed the cattle, where we nurture the cattle. For the next, we harvest the milk, and cows produce. And between the systems, we have interactions and interactivities, and we have to manage that, and more data come into the game. And at the end of the day, I can, as a farmer, I can sell beef, I can sell milk, I make money, I have to spend money for fuel, for workforce, for whatever, and I produce greenhouse gas. So, and now, for example, questions come in, how can I balance that optimally depending on my trade-offs? And this picture should show that a typical farmer is in front of the question. So the bottom left picture shows, for example, a dairy and livestock farm producing corn silage, as an example, and the right-hand one is producing grass. Both is useful to feed cattle, but there are pros and cons. It's about the health of the cattle. It's about the amount of milk produced based on silage food, based on grass food. It is about, on the left-hand picture, you see a slurry tanker bringing the manure to the field. This is perfectly good because it saves you some fertilizer. On the other hand, you may have some nitrate going into the groundwater. So pro and con. And you have to make decisions. And that's pretty complicated. And at the end of the day, the farmer lives from that. He makes money with that. If he makes, at the beginning of the season, the wrong decision, he has a real problem. And at the end of the day, if farmers have a real problem, I tell you, who had milk for breakfast today? If the farmer has a problem, it is just a question of time, and we have also a problem, right? We cannot go around that. So the question now is, how can we make it more efficient, more productive, even from our side, from the John Deere side, to understand that, to model that, to make it useful for our business, for our engineers. And we want to do sensitivity studies. We would like to generate requirements for our tractors, for our balers out of that. And as I said, that for more than a decade, we are around with systems engineering. We tried doing that in SysML, but we pretty quickly came to limits. We had to introduce stereotypes, the different stereotypes, different kind of views, customizations in the tool. At the end of the day, you are not compatible to anyone else outside. So it's possible, but it's not useful. So we came to the point that we looked around and said, okay, what could help us? And we found basically everything invented, right? Everything there, just take it. And we stumbled over UAF and found, okay, most probably that's focusing on system of systems. Actually, a farm is an enterprise, just a different viewpoint to it. And we have everything we need. We have capabilities, we have operational scenarios, we can provide different viewpoints. It is close to SysML. It's not exactly SysML in the first moment, but it's close to that. And we have everything available we need from a documentation point of view, from a trainings point of view. So what we did is, because we haven't had too much time, we did what we typically do. We looked for partnership, for friends, for supporters, and we found, and one of my colleagues sitting over there from the company, Bertrand, Ray, he did most of the legwork of modeling. Lift your arm that people can see you. So that's Ray. And he approached the company Dassault. Thank you to Dassault, Aurelius, and your friend over there. So they provided us a training from zero to hero, very nice training, very comprehensive, excellent. And we started building up a model of a dairy and livestock farm. And actually, we got confused by that scary grid. That's how you called it, Aurelius, right? The scary grid at the very beginning, until Edita told us, don't look to everything. You pick what you need. And I thought about, man, that's exactly what I'm looking for, right? It's make it simple, keep it comprehensive. And so we dived into UAF, and actually we identified, okay, we have everything we need to model a farm. We can define higher goals. Would I like to improve my economical margin? Would I like to reduce my environmental footprint as a farmer? Would I like to grow my farm? It can be different goals. I have capabilities. I can divide that in operational scenarios, so everything there. And now we started diving into the depths. And unfortunately, I cannot show you here in detail what we did, and you have to imagine it a little bit. On the UAF side, we now started with our agronomical knowledge to model the use cases you need to drive a farm. So we have their elements in like slurry tanker operations. We have elements in like harvesting crop, like compacting silo, like taking stuff out of silo. We have different machinery. We have tractors. We have mowers. We have balers there. So there is farm people. Like the son of the farmer in our model farm, the son of the farmer is partially working on the farm, but he is not that skilled in driving a tractor like the contractor. The contractor is doing it since decades. He earns his money with that, so he has better skills. So in our model, the contractor has a higher efficiency, more area in the same time with less fuel. And this can be modeled here. This is perfect. This is absolutely perfect. And we can generate out of that, we can connect it to our SysML models of our platform systems like the tractor, like the mower deck or the baler or others which play a role in that. And so what we did is with a lot of good old handwork, and again, thank you to the company Bertrand and those smart folks, and thank you also to Dassault, who supported us when we struggled and had the question, is it more resource or is it more a person, or how to treat it and what are the trade-offs of that? So we could basically set up everything we needed for a dairy and livestock farm. And that are now some simple snapshots out of the bigger UAF model. And what you see in here, the blue picture at the top is basically exactly the same like the PowerPoint picture I showed before with the prepare the ground. It's just turned around. So we have the animal food production here on the right-hand side. No, it's on the right-hand side, and on the other picture it was on the left-hand, and the animal production on the left-hand side, and that was on the other picture turned around. But we modeled that as operational scenarios, and we have also the possibility to map, to connect capabilities with operational scenarios and to parameterize and to set up a nice model containing everything which you need for whatever farm at the end of the day. And we just started with dairy and livestock. You see here an example cut out of the model from one of the farm products, so diving a little bit deeper into the detail. So on the food production side now, we look, the big block on the bottom left hand is the grass silage clamp production. So now we decided we would like to investigate what does it mean if I have to cut grass, if I process it in a forage harvester and put it in a silage clamp, which is pretty common in Europe. I think it's not that common in the United States. And I can see what kind of resources are tied into that, what kind of parameter are behind that. I also can work with that like in real life, bringing it into dynamic context. Actually, it is static, but I have something like states. I can move from state 1 to state 2, and I have sequences and I have activity flows which I can model. And what you, for example, see here is for that grass silage clamp a typical process flow, a typical sequence diagram based on the capabilities. And and we had yesterday at dinner on that, where I said, for me, one of the favorite numbers on our planet is 23.5. You know what 23.5 is? The inclination of the axle of our planet. And that's why we have that seasons. That it doesn't, it is not, you made the perfect example with the gardener. If I'm a watchmaker, I can wake up at 2 o'clock in the morning and start building a watch and then can finalize it whenever I want. If you want to go out to your garden and grow whatever, beans or whatever, and you put it at the wrong time in the ground, you can forever. There will never be a bean out of it. It has to fit to the 25 degrees. Nature's can say like that. I would say that it's not very willing to take compromises on that. So, and this can be built up here with the season. So we have a season model behind that some stuff has to be done in spring, some stuff has to be done in summer, and so on and so forth. That can all be tied into here. And last but not least, we also have the possibility to parameterize that and to prepare it for simulation. It is intendedly, you cannot read it here because we spend also a lot of time and effort in all the agronomical data. So the data, the underlying data that has to be said also is something we really went out and interviewed a lot of our customers. How are you doing dairy business? How are you doing small grain business, cotton business, whatever? And we sampled the data to say an average milk farm in, let's say, Germany has about this number of cows, this equipment, this people, this buildings, this logistic structures, infrastructures in it. And it is different. I can tell you it's different if you see it in Germany, in France, or in Milwaukee. At the end of the day, it is milk which comes out, but the boundary conditions are different. And we have good numbers for that, which represent that. And yeah, I cannot show them to you, but they are now part of that model. They are in that model And with that now, we can build clear architectures, clear hierarchies, where what you see in here, basically from the left to the right, you see that the production system as the initial point, as the core point. You see different concept of operations, different production steps, and that goes then to different solution systems. And at the end of the day, you see what makes a tractor designer, the tractor developer happy. You see that in different of that solution systems, the tractor plays a role, and he has to fulfill at the end of the day, he has to fulfill requirements coming out of all that chain of events, all that chain of consequences. Now, the point is, until that, and I don't know, one of my prior speakers said that also, before we did that all in UAF, guess what tool we used? Excel, exactly. So, and the thing is, the folks doing that studies, that sensitivity studies, they do a great job. They investigate for us what is the point to focus, what is the point to put the resources in the development effort. Is it better going into automation, or is it better going into more fuel efficiency? This comes out of those folks, but they are no UAF experts. So what they need is, they need a user interface which they can easily and quickly apply, and which is comfortable to them. They should not be afraid about using that model, right? It should be something where they say, hey, let's do another study, let's do another sensitivity case, whatever. So we also spend some time, and again, thank you to Bertrand and Dassault for the help to develop an Excel-like GUI that those users of it can in it without that they can get quickly graphs and results and easily interpretable results also for management to say, hey, if I don't put the manure anymore on the field, if I put the manure in a biogas power station, this has on the money side this consequence, on the greenhouse gas side this consequence, and under these circumstances that's a choice to do. On other circumstances, maybe in France it's worse to go that way, in Milwaukee maybe not, because of legal regulations that all can have an impact here. One of the points, and I'll come to that in a minute again, is user-friendliness and usability overall, which is obviously in UAF something to be improved, but it could solve all our problems. We could run the simulations, we could generate the output, we could verify and validate that with our prior models, with our real customers, and found a nice way. So now, the original task was not only to reproduce what we had until that time in humongous Excel tables and Visual Basic scripts underlaying and whatever. We also want to have a digital thread, a machine-readable digital thread coming from the top level where our business is basically defined down to the platform. And we would like to connect that to our SysML models. And also that was possible. You see that here in that picture on the bottom left-hand side, that we have our system, we have our measures, our operations, our capabilities, and they generate stakeholder needs and requirements for our platform systems, and we can easily match them and can use them directly. And this is a really caveat in it, because that means that we can move now from a non-machine readable Excel table, which has some miraculous formulas in, to a machine readable digital thread from the production system to the platform, which is capable to all means of intelligence, of digital connectivity. This is a real benefit to get hands around the management of complex systems. With this said, and actually I would like you to have some chance to pick some food for lunch, so I try to stay in time here. I like to conclude. So we started that, and actually we started not too long ago. We started about 1.5 years ago. It was a pretty quick jumpstart, and again, because of the efforts we put in, we had a steep learning curve and we had good partners in that. So this is obviously a tremendous advantage and benefit in the means of digital thread and digital twin. We could prove that we can connect the models, that we can build an interconnectivity, and we can easily simulate stuff, and we have much more performance and capabilities than with the old stuff we used. On the other hand, we have to work on the interfaces to the non-expert users. We have different layers. We have those who should work on a day-to-day basis with that models. We have obviously those who should maintain the models, and we have to federate models. So I heard you, and that's important because a model has to be valid and has to be verified. This is not an easy thing, so we need different skill levels even in going around with that. We have are interested in what happens with the move to SysML v2 and the programmability capabilities of SysML v2 and the automation capabilities. So we are really curious to see what comes out of UAF. We work currently, Ray reminded me to say that with the version 1.1, not 1.2, so we haven't had really the value streams in it. But obviously, we will continue that and dive deeper into it. So coming to the real end, the proof of concept worked well. We will continue now a pilot, which is focusing basically on the day-to-day usability, having product managers, having marketing folks, having portfolio managers using that models for sensitivity analysis, concept studies, whatever. We compete to Excel. This is a clear challenge we have. We are not hiding that. This is everybody can be proficient with Excel. Why not with UAF? And we continue partnering with the experts to continue our steep learning curve, to get further benefits out of that. And I tried to introduce a new, very complicated abbreviation there. So we try to go to the model-based system of systems engineering. And I guess that is something where we will have, if we want or not, a combination of that enterprise modeling languages and system modeling languages. So with that, I started with the SysML model. I would like to stop with the SysML model. You see my heart blood is model-based systems engineer. And I thank you for your attention. And the thank you means and in that diagram that you now have to appreciate me, and then we can go in the loop of questions. So thank you very much.
Thank you. There are some questions online, so I will read those and then we can go to the audience. There's one question. Why did you select UAF specifically for your model? Yeah. Just curious.
Yeah, basically.
Why not DODAF, by the way?
Yeah, we looked basically around to something which is easily available in a let's say in a commercial tool environment and with trainings material and documentation, and we haven't had too much time to make a decision to that. We looked into different architecture frameworks and found basically that with the plugin in Cameo, where we do our model-based systems engineering with the documentation, with the trainings capabilities, it had some benefits over the other architecture standards. Maybe if we would have looked for different parameter, we may have decided for a different architecture framework, but pretty simple, pretty pragmatic.
All right, and one more. Have you considered the farmer and DNL SysML owner while modeling?
Yeah, yeah, absolutely. It is not at its end. So we have the farmer. The farmer is in the model in different meanings. So he is in with his skill set. He is in as a process element for the financial flows, for the logistical flows. So he plays different roles. It is clearly in, and we would like also to go down a little deeper and also see, for example, to distinguish between milk cow and cattle and different behaviors and kind of that. So there are some promising things in that farmer's element. Yeah.
This is Greg Gaines. I'm from SAIC. Krishna, how long did it take you to get to this point? From when you started working with SysML and UAF?
Help me out, Ray, that I don't be too optimistic. I would say 1.5 years.
Very
About something like that. Yeah.
Right. One more question. We can take one more question. Here.
Hi, good morning. Clay Dolaplane from US Transcom. Can you begin to quantify the cost of all of the interviews that you performed with the farmer?
Basically cast it into an Excel environment, and the interviews and the investigations happened to set that up, and we just reuse that. On one hand, honestly, I don't know how much cost we spent. I know that we had hundreds of interviewers out for a long time, for months, doing interviews. I guess you are clever enough to calculate on your own roughly what it means. But we use that. So the 1.5 year is really saying I have an Excel model farm here, which is not sufficient, not machine readable, really connected to my tractor model. And I would like to translate it in UAF. And we contacted, negotiated with Bertrand, negotiated with Dassault, and said, come on. This is the one and the groundwork in the data that was all done before. And we started in 20 to migrate to the production system, and I think that was a time when we really started looking into deep to investigate how the agronomical side of our customers works. I would say this is basically where we really started looking in detail into it with effort.
Right. Thank you.
Thank you.